Okay. Now continue to the previous video. I'm going to start a problem on circle diagram. So this is the problem with the given data. Draw a circle diagram for 20 HP 50H three-phase star connected induction motor with the following data. It's a no load test data. It's a block rotor test data. So no load voltage given as a 400 volts, current 9 amperes, no load power factor 0.2. Short circuit test or black rotor test data is 200 volts, 50 amperes, and power factor is 0.4 lagging. So here we have to find out, we have to draw a circle diagram, and from the diagram we have to find out line current efficiency, all these parameters. Let us. So first we have to find out the no load power factor angle. So cos pi naught is given as a 0.2. From that I am measuring the power factor angle. It is 78.46, and from short circuit data pi SC will be 66.42, and no load current is 9 amperes, and short circuit current is 50 amperes. So this no load current, if you convert into current scale, I am choosing 1 centimeter equals to 5 amperes. So this will be equals to around 1.8 centimeters. And I am going to calculate the no load short circuit current, that equals to ISC into VOC by VSC. So that will gives you 100 amperes. 100 amperes current scale will be equals to 20 amperes. And similarly, I am going to find the short circuit power. So using this formula root 3 base AC cos pi, so I am getting the short circuit power as a 6928 watts, and WSN load short circuit power is. So using this formula, I am going to calculate this one. That will be around 27712.81 watts. Or else you can use this formula also, root 3 VL ISN cos pi AC. This also you can use. So then after calculating these values, now we have to draw the circle diagram. So I have chosen no load current 1 centimeter equals to 5 amperes, no load current 9 amperes equals to 1.8, and we have to draw the circle diagram with respect to V axis. So voltage Y axis, we have to take V voltage phasor as a Y axis. So with respect to Y axis, we have to draw the no load angle and no load power factor angle, short circuit power factor angle, both we have to draw with respect to voltage axis. So this ISN current we calculated already, that will be converted into current scale equals 20 centimeters. Now if you see the figure, so from this figure with respect to voltage axis, this pi naught is 76.42. So this total is 90 degrees, means 70 somewhere else you will get here. So with their no load current 1.8 centimeters I am placing on this line. So here 1.8. So from here I have drawn a horizontal line like this. Then to this line, this is parallel to your x-axis. So this O dash B line you have to draw this one. Then after that, with the no load the short circuit power factor angle pi SC we have to mention with respect to phasor V. So then that is 66.42. So this is the angle is 66.42. So with the dotted line I am extending this line up to point A. So there with ISN we know it is 100 amperes. So converting to centimeters, it will be 20 centimeters. So from O to A it is a 20 centimeters. So this dotted line, if you extend like that from O to A, this is 20 centimeters. So now we are getting a point A. So from A, already we have the O dash A. So O dash A you have to join. So this O dash A line is called output line. Output line. So like this we are getting the output line. So now we have to make a perpendicular bisector to this O dash A line to get a center point. So O dash A, taking more than half of the distance, I am drawing these arcs here and here. So if you join these two arcs, that will cut the O dash B line at point C. So this is your center point. So O dash C as a radius, O dash C as a radius, draw the semicircle. This is a semicircle. So like this, we have to draw the semicircle. Now next, I already calculated the output line. So output power, it is given as a 20 HP in the problem. So power square also I calculated it. So the length will AD. So when you draw a semicircle, A will exactly comes on the circle only. So from that A point to draw perpendicularly downwards to x-axis. So that cuts O dash B line at point F and x-axis at point D. So this is your total losses. From A to D is your total losses, and F to D is a fixed loss. This portion will give you the fixed loss, and A to F is your total copper loss. It's a total copper loss from A to F. Then, so power scale I am calculating that length, A to D length, I got it as 8.2 centimeters from the graph. So then 1 centimeter equals to 3317.61. So this is your power scale. Like this, we have to convert watts also in terms of centimeters. In the given problem, full load output given as 20 HP. This is equals to 4 in terms of watts, and this also I am converting into scales. So per centimeter equals to 3379.61. So it will use 4.35 centimeters. So now draw A dash with 4.35 centimeters to locate full load point. So A dash with 4.35 centimeters. Now we got point A dash. So similarly from point O dash also you can keep 4.35 centimeters. Now draw a parallel line O dash B to the output O dash A output line. You have to draw a parallel line. So this that parallel line will touch the circle at point P. So this is like this. You have to draw a parallel line to the output line. With 4.3 centimeters, we are getting output power here. So here also this distance will be 4.35 only. So that parallel line will touch the circle at point P. So now you have to draw a tangent to the circle. So that distance OP will give you the full load current. This will give you your full load current. So using the scale, if you measure, it will be that will be 6 centimeters. So 6 into 5, 30 amperes. So your full load current is 30 amperes. And similarly, the power factor angle also you can calculate. So this power factor angle, this angle is your power factor angle. Or else you can also find out this value from this triangle OPT. From the triangle OPT, the cos pi is PT, distance PT by OP. Then also you get the power factor. Next, we have to draw torque line. So how to draw torque line means, so the distance from A to F is 8.2 centimeters. If the rotor copper loss and stator copper loss are equal, then you have to find out a center point. If it 8.2 means 4.1. So 1, 2, 3, 4. So 4.1, around 4.1 you are getting, you have to neglect this one, fixed losses. So here it will be around 4. Then that value will be divided into equal. So this is off and here is off. So it is a rotor copper loss. This is a stator copper loss. So the remaining is fixed loss here. So this is equally divided if both losses are equal. So at the center point E, you should draw a line from O dash to E that will use your torque line. So like this, we have to draw output line and torque line. Then we have to find out the maximum power and the maximum torque. To get the maximum power, you have to draw a perpendicular line to the center. So output line, this is your output line. So this output line you are drawing a perpendicular to the center line, center point. So if you draw a center point to output line is perpendicular, that will extend that line, that will point touches the circle at point M. From that point M, you have to draw downwards a vertical line up to the output line. The distance MN is called the maximum power. So you have to measure this one, multiply with the power scale, then you will get the maximum power output. Similarly, torque line, you have to draw a perpendicular from the center to the torque line. From the center to the torque line, you have to draw a perpendicular. Then that will touches the circle at point J. Then extend this line to the torque line, straight vertically downwards. So this touches that point K. The distance JK will give you the maximum torque in synchronous ones. So these are the various parameters you can measure. And this L dash from the center, if you drop vertically, so that is the maximum power. So it will give the total input power L dash. This is L dash. So this is your total input power. Like this, we can calculate all the parameters. So already I given the formulas for different parameters. You just to go through that one. So based on that, whatever the value you want to find out, you can find out. For example, I'm showing here the efficiency. Efficiency in the formula, it is output by input into 100. So where output, so this is total power. So P to T is a total power. P to T is a total power, and P to Q is the total output power. P to Q is your total output power. Then this is your rotor copper loss. Q to R is your rotor copper loss. So the total power which you are given to the rotor is P to R is your total rotor input. Then Q to R is your rotor copper loss. The remaining is a total output power. And this S R is your stator copper loss. S to R is your stator copper loss, and ST is your fixed loss. So the total input power is fixed loss, stator loss, rotor loss plus rotor output. Then this PT will give you your total input power. So from this you can calculate all the parameters. So efficiency is output by input. Output is PQ and input is PT. Make the correction, it is a T. So PQ by PT. So into 100. So like this you can calculate the efficiency. And slip is rotor copper loss to the rotor input. Rotor copper loss in the figure, rotor copper loss is QR. QR to the rotor input. So PR. Rotor copper loss is QR. Rotor input is PR. So then you will get the slip QR to the PR. Video slip. So like this you have to find out the parameters of from the circle diagram. Thank you. Next video I will solve the shown the video of circle diagram construction. So you can, if you want, you can check that also.